Hello, everyone. Thank you for attending today. We're going to talk about Editor VR. And the takeaways for today are I'm hoping you'll walk out with embracing design ambiguity, in your productions. And I'll talk a little bit more about that. I'm also hoping that you'll walk away with, for you software architects out there, architecting for adaptability and really embracing change in your production. And then also we're hoping to show you how you can build your tools up to meet your team at its level of creativity. And I like to refer back to a 1993 essay from Paul Graham. It's called Programming Bottom Up. And if any of you know about the Lisp programming language, it's one of those languages where you kind of build up your language to meet you where your actual where you need to program at your application level. So my name's Amir Ebrahimi, and this is Matt Schoen. He's going to be coming up for a portion of this as well. A little bit about Matt. He's a computer engineering graduate from BU, and he co-founded, sorry, I've got the Steam VR thing in the way. He co-founded a studio called Defective Studios. It was a Unity-based studio, and he's a senior engineer at Unity Labs.
Hey everyone, I'll be back up in a bit, but I'm going to go chill out while Amir does the first part.
And then I've worked in games and visual effects for about 15 years. This is my second time at Unity. In between, I formed a mobile game company called Luminary. We made a mobile game, and it didn't do well, and we shut down our offices. So I'm sure that might be the case for some of you if you've had that experience. So at Unity Labs, we look to explore problem spaces that are 1, 3, and 5+ years out. And we're looking at that so we can advance the authoring process and be ahead in terms of where we might want to take the product in the future. And one of our projects was Editor VR, and I'm going to show you a short video of another tool actually called Scene Fusion that makes use of Editor VR. But I like to show it because it's just a cool video. It shows multiple people editing together in the same session with Editor VR and one person on a laptop. Yeah. It should be audio. Okay. Yeah. That's a good level too, because for the rest. So I like that video because it's indicative to me of where we might be heading with authoring in the future. I mean, right now our authoring processes are very asynchronous. We're working on this common world together, but at different points in time, and integrating our assets together. But let's switch gears and talk about what it means to architect for adaptability. So in 2015, we set out with the experiment of how someone might author VR inside of VR, and there were many challenges with that. So, from a performance standpoint, Unity's running as an editor, and it's not just that we have to do VR, we have to do all the editor stuff, plus VR, plus leave you a little bit of room so your own content can run performantly in the editor. There's one of the things where we can't really modify your scene without your express permission as a user, so we have to keep your scene very clean, and that was its own challenge. But today we're going to talk about one of the challenges, which is just architecting something that's extensible and adaptable. And eventually we're going to get into actual live demo of how you would build tools with Editor VR, and how you can build it to how you can use it to build custom workflows for your own VR projects. So let's rewind back into 2015 when there were only DK2s around that we were working with at the time. And we didn't have touch controllers, so we all used Hydras. And these were controllers that were, I think they were magnetic based. And they were made for gaming, and they had come out many years prior from a company called Siggraph. And then they didn't sell well, so they stopped making them. But when DK2s came out, it was very popular that you needed hand controllers. And we were buying them at, I think, $300 a pop off eBay, just so we had something to work with. So the reason why I'm sharing that story is so that you can understand it. Like 2015, we were building with hardware that we knew was going to change, and we wanted to have systems that allowed for that change and allowed us to plug in new controllers when that would happen and not have that completely destabilize the whole system. But initially we started with a prototype, and that's the hardware we use. And then in January 2016 at our own Vision Summit, we unveiled Scene VR at the time. That's what we were calling it. And it was just a prototype. And it had some of what we had has lived on, but we got rid of a lot of other things. And but at the time we were building this prototype, we noticed that every time we wanted to try out a new locomotion system or a new way of moving objects around in the scene, that the rest of the system would be destabilized. Like there were so many dependencies across our systems in the prototype. And it was a prototype. So the unfortunate part is when you demo something, you keep needing to show progress in terms of future demos. So in June 2016, that was our final demo at Unite Europe. And I was sitting there with our team and wondering, when are we actually going to reboot this thing? And we had started already in June to have more architectural discussions about what we were going to do for the long term. Because it's not just building a set of tools, it's also providing a platform that you guys can continue to build your own tools and potentially sell these on the asset store if you're a Unity developer that does that. So what was our solution? It was to decouple, and that meant we wouldn't use any singletons. Actually, let me get an idea of how many programmers are in this audience. Okay, yeah, majority. So I'd probably say 80% of you are programmers. So yeah, no singletons in the system. And also an architecture framework where no spawned object is ever reaching up to its parents to do anything, or even reaching laterally to other objects in the system to do that. It's given everything it needs. So how do we do that? We use interfaces. And the first, normally use interfaces as contracts, and we'd certainly use that. That's the standard use. But we've kind of morphed interfaces into this thing we call functionality injection, where you would, and you'll see this when I demo this later, where you actually implement an interface to receive services from the system. And we wire those up in the back end. And the hope there was that you could also wire up these same interfaces to your own systems if you ever wanted to use them at runtime, assuming you would use Editor VR as your own framework for your system. And what this does, it allows you to enumerate all your interface variants. So for locomotion, if you implement iLocomotor, then we can enumerate all those and provide those in a menu. Well, that's the standard use of interfaces, but that allows us to easily swap out locomotion systems. So the big takeaway is, my hope is as you architect for VR, you build systems that embrace change. Frequently as engineers, we'll have designers come to us and they'll ask, hey, can you do this thing? And you're like, no, because you asked me a month ago to do it this way, so I designed the system around that. So I'm really hoping that with VR, things are changing so fast that I think we need to build systems that are able to change, and that as engineers we can actually say, yes, let's do that, let's try that. And there's no internal resistance as an engineer to not wanting to try stuff out because it might be difficult. So you can check out our code. It's on GitHub. All of Editor VR is open source. And that's a simple bit.ly link to the interfaces part. Originally we had it as, because we were also moving very quickly, originally we had this one monolithic method that wired up all the interfaces, but that's since been decoupled and is more decentralized. So I'm going to switch over to Matt. He goes by Schoen. And he's going to give you a live demo of Editor VR just to set context in terms of what you can do with Editor VR, and then we'll talk a little bit about VR design after that, and you'll take that too.
Thanks, Amir.
Yeah. So you should be good to go.
So
here's the weird thing. We're going to switch to duplicate during this part,
right, okay.
So you can see that. And then you probably want to use
the Siggraph
scene.
Yeah, okay. So yeah, we're going to open up this scene here that has a little bit of interactive, but mostly just kind of visual set elements. It just gives us a nice kind of idea of like what it looks like to work with the scene at a point later in development. The scene wasn't made with Editor VR, but easily could have been. And you know, it's up to you whether like how you want to use the tool. Either you can use it to make tweaks, you could use it to build out the entire scene, you could use it for prototyping. But anyway, this is what you get. I press Control E to bring up this VR view, which I've now has covering all of Unity, but I can still use the editor while I'm doing Editor VR stuff. I can still click around. The scene view is still active, but this is just so you guys can see all the pretty VR stuff. So the first thing that we always want to try is like how do I move around? So there's a couple different modes and a couple different ways to do it. The easiest way is just to press the B button on the Oculus Rift, or I think it's the menu button on the Vive, to just sort of fly in whatever direction you want to go. You can use both hands too. You can hold the grip and hold B and now rotate the world in place. Keep flying around, and you can like hold the trigger to fly faster if you need to go super fast. You can also use both hands to move, rotate, and scale at the same time, which is sort of how I got to this bird's eye view here. What you might see like starting out at human scale is a world that looks like this. But being able to scale the world like that is just a really useful way of kind of getting to the viewpoint that you want. We also have a blink mode, so I'll show you the menu in more depth later. But now that I've switched to blink, my B button is going to give me this little blink cursor, and blink is generally more useful. Sorry, I'm losing tracking here. Uh-oh. I've lost a hand. Hang on a second. Could be batteries. It's not bothering me about it, but I'm just going to reset. Live demos, folks. Yeah, no, that's dead. Unfortunately, you need two hands to use the tool, so yeah. Thanks. Awesome. All right. Cool. Back up and running. I got a little fog in the HMD. All right. So yeah, now I can sort of blink around. Blink is best done when you're human size, but this is sort of like, it's sort of more useful, I think, for a presentation of the scene, or if you want to kind of emulate what your game might be doing if you have blink. But anyway, we always want to provide a number of different ways to move around the scene and kind of account for any sort of environment you have. Maybe you're in space, maybe you're in a scene like this, maybe there is no ground, maybe there is like a really hard idea of a ground. So we want to make sure that this is can accept any kind of scene. Another thing you might be noticing here is like as I move my cursors around, I see these things highlighting, but not necessarily around here. So we've added this locking feature where these objects are regular game objects. They're visible in the hierarchy, but I can't actually select them and edit them, so that if I want to just move my interactable stuff around, I'm free to do that. So yeah. So what Amir is going to be showing you later on in the talk is this sort of like we've made a custom tool to make this archery game work together. But I'm just going to show you like if I wanted to build out more of this scene. I've selected the object. I'm going to go and clone it. Oops. Yep. And now I can grab it and pick it up and move it around with my hand. I can scale it if I want to, or I can manipulate it from afar with this axial and rotational manipulator. Another really sort of nice feature that you won't be getting in the normal 2D editor is snapping. In this, well, sorry, we have snapping, but this kind of surface snapping where anything that I touch this thing against, it's going to sort of intelligently figure out what two surfaces are touching, and I can't push it through any further. And again, this is something that we can enable and disable in the menu. Oops. And now I'm just sort of moving them freely without any kind of snapping. Put snapping back on. Let's see, what else is there to show? So we have this menu that I've been using. You activate it by pointing at the Unity logo, and then it will sort of appear and disappear. And we have a number of workspaces, which is sort of the editor VR equivalent of a window. So for example, if I bring up the project workspace, I can now move this around freely. I can resize it. I can close it by pressing this button over here, and I get the project view that you might be familiar with from Unity, where I have folders and files on the right. So I can go and look at all these prefabs from this. Well, yeah, so I have the prefabs from the environment pack with all the flowers and trees and things that I can kind of pull out, as well as what Amir was saying with the Longbow folder has our interactable, the Weeble, for example. I can pull one out if I didn't already have one in the scene. Yep, there we go. And yeah, again, sort of similar interface to what you might be familiar with in the regular 2D editor. I'll close this guy and show you the mini world, which is kind of a very VR-specific feature. It allows us to kind of frame and manipulate parts of the scene that we're not necessarily in right now. So say that I wanted to maintain my kind of human perspective and see things around me like so. I can still zoom out and manipulate the scene. I can pick up this tree and put it down over here, and things will still respect snapping, and all that stuff is still possible. I can even take another mini world, put it somewhere else, and then like grab this tree, drop it there. There you go. Yeah. So not really a concept that like translates to any other kind of editing, but it's also just something really useful if I have all this stuff in my at sort of at arm's reach. Let's see. We have our, so this is an example of a tool. Amir's going to show you later how to make a custom tool, which is going to be sort of specific to this particular gameplay use case, but our example tool, which is also kind of reflected in the normal Unity editor, is we can just create primitives on a whim. I can select, say, a cylinder and pull one out of there. And what this is giving us is we have a menu, we have something that can be done at the tip of the controller, and we have a mode that we can switch in and out of. So we have this little icon that's going to show up down here to toggle it on and off. So now I'm not going to do any primitive stuff. I can select with this hand, or I can toggle it back on, and everything I do is going to be making primitives. So yeah, I think that's probably a good amount of context. Let me just make sure there's nothing else. Oh yeah, everyone always wants to see, we can bring up these editor windows that you're used to, interact with them, get some profiler information on what's going on right now, as well as hopefully not see any errors on the console. Yeah. So yeah, this is how you interact in VR, and I think it's about time to kick it back to Amir.
Sure.
Maybe. Sorry, I got a little nervous during that controller meltdown. There you go.
Cool. Thanks.
Cool. Thanks.
Oh, not extend. This is always fun. I'll just do duplicate, and we'll get rid of the speaker notes. Yeah, this transition almost never works. So generally, I have a bit about how to design VR apps. I'll give you enough time if you want to snap that, but I'm not going to go over this because I realize we're short on time. Yeah, we only have like, yeah. Well, I'm gonna go through the whole process of building something from the ground up. So, well, one thing I will point out is right now I'd say build for the market, if anything, that we have today, not where you think it's going to be in the future. Like make it work for what population of VR consumers we have now, if you are looking to be profitable. That would be my one point to throw out in terms of designing for VR today. On the user experience side, I won't call out all these. I'll just call out one, which is I think the near field. There's something. Well, Jesse Schell talks about this. There's actually stuff in the brain that activates when we have stuff in our near field. So I think that's a special thing that we have at our disposal as VR developers. So that's the 0 to 4 meter range. And then on the maintaining frame rate, that's super key, like 90 FPS. And if you went to Alex Vlachos's talk at GDC, you don't actually get a full 11 milliseconds because you got to consider that the OS is going to be doing some things. So maybe target 10 or a little bit below that. And then the one thing I'll call out from this slide is that profile like often and early. There is no like making things run faster at the end, especially for VR. And if it doesn't work, then make it work before you move forward, even if it's like all hands on deck. So we've shown a lot of scene editing with our editor VR demos, and I wanted. There's much more to editor VR, and the framework's built that way, in which there eventually will be animation tools and other tools to hopefully encompass all of your authoring inside of VR. And one of the things that we were starting to discuss is, well, how would you actually build a game, in VR? And that's where what this longbow experiment was. So I'm going to show you a video of what, because this comes from Steam VR's SDK, what longbow is, so you know what the game is, and then we'll go into how to create tools for that. So you get the idea. So our experiment, what we're going to do with the time we have left, we're going to set up a basic framework just to allow us to set a bunch of these targets. So what you saw was actually from the lab, which you can download on Steam VR. But in the SDK they only give you the longbow and the Weeble. They don't actually give you the full art assets for that project. But with that, we can create our own component to allow us to sequence these so that we can shoot these Weebles in order. And then we're going to iterate on that using traditional means just to really drive home what it would be like to have a 2D workflow. And then we're going to switch over to using Editor VR and build out a custom tool that I hope will land on you that your designers won't even need to know how to use Unity to do this. So yeah, let's switch over. And so for the engineers here, I have two options. I've got a bunch of stages of code. This is interactive, this part, okay? So I've got a bunch of stages of code that I'll take you through just to show you what you would normally encounter along this process as you build your own tools. Or I could, I used to do this demo where I'm hammering out code on stage just to show you it could be done in 1 hour, but that's kind of a waste of your time. But the other option is I could actually do it live and just copy pieces of code so it wouldn't be like me reading over or showing you the code. So I'm gonna take a poll So option one would be we just go through the stages of the code. I'll throw it up. And briefly, I mean, you guys are all great engineers, so you'll get what this is very simple. So, or I can go through it. So let's get a show of hands for that, if you prefer to have it just be brief and I show you the code. Let's see, that looks like about, shoot, 50. I was hoping it would lean more. Okay, and then the other option would be, still I won't write code, but I'll copy it and I'll have like a single file. And let's see a show of hands for that. Okay, actually we're gonna go with the first one. Cool. So let's switch over to Unity. So I'm gonna switch to, well, first let me show you. If you were to bring in Steam VR, you're gonna get this folder, and you're gonna get, they bury this way down in here. You're gonna want, they have a scene. It's not the example scene. That's the weird thing. It's there is a separate interaction system with scenes there. And if we go into that, you'll see that they have a bunch of different interaction examples. And if we were to run that, the reason why I picked Steam VR was just because the bow and arrow, it has a good tactile feel to it, and most people just get it, and when you shoot it, it just kind of makes sense. So I think it's a good thing to demo, if it worked. Let me see what's going on. Demo fail. No, Steam's running. I might just, Unity is, something's happening. We're gonna restart that. It might be all the switches with video stuff. Yeah. Unity. All right. All right, so if we look at the interactions example, there we go. There's some UI stuff. There's some things like throwables. You can just like pick up boxes, but that wasn't something that I could build a game with, and I was very much interested in showing how you could build a game. And over here we've got this longbow. So one of the first things you would do if you were going to work from that, and I would suggest this, is reduce your iteration time. So we stripped out everything else that we didn't need in the scene. And not only that, even that teleport at the very beginning, strip that out. Make sure that I start right next to the thing so that I can just pick this up and shoot it. So once we have that scene, then we would add this, we'd add one of these weebles, or two of them, and we would have this script that we created called a sequencer node. It's a very simple script, although this has changed a little bit. We just need to set the next thing that we're going to enable when this thing is completed. And for the first one, we need that to stay enabled, so we added a checkbox for that. Because obviously you need something to shoot at the very beginning. The way SteamVR already has things set up, they use our event system. So once this thing takes damage, it spawns a balloon. So we just hop into that and we send a complete message to our script here. So I'll just show you very quickly what that looks like. Just so we shoot this, and then it goes to the next one. So that's the game. Very simple. And the code for it, it's split between two source files because we now allow teleporting the player as part of this game. But most of it, this is how simple the code is. And then the rest of it was here. We just have a simple crow routine that waits a few seconds before it goes away. Otherwise, the balloons would pop out as well. So that's our sequencer node. So So, okay, let's say we wanted to create more gameplay. Well, how do we do that? So we might copy some of these. I might take this one and duplicate it and then move it out here. But setting it up, and you could build a 2D set of custom 2D editors as well in Unity. That's possible. But as you'll see, it's just much more intuitive in VR. But if we were going to work this way, we'd select one of these objects, and then we would drag here to this property, the next one. And we don't really, other than clicking on this one, like clicking on the inspector and having it show us what the next object is, we don't really have any good visualization for the order of these things. So this new one I added, I could just wire up by dragging it to that field. And then let me make this, I'll just move that out a little bit farther. So that would be like another wave of our game. So I shoot that, and then we get that. So you can see how the game works. But let's say we get to a point where maybe we're not, we're not very good at shooting these, and we want to make adjustments. Of course, I got to pull the headset off, switch out of play mode, and then make adjustments and go back in. So that's the point that we're hoping to solve with Editor VR. So let's look at what custom tooling might look like. So I'll start with the first sequencer tool that we're going to put in there. So one of the things we want is we want to show lines between these things, so that we can see the order that they're going to get, the order that they'll go in. So I'm just going to, this right here is just a way to hide something in the menu that Schoen was showing you. You can disable that, but I'm going to enable it now and give it a name and a category that it should show up in. We needed a prefab for the line rendering, so we created this prefab here that is a very simple, it's down here in the tooling. We call it sequencer node. It's simply a line renderer that we'll set two endpoints on. And our code is, at the very beginning, we're going to collect all of the sequencer nodes in the scene, and then we're going to spawn those line renderers, set the endpoints every frame, and that's our simple tool. The only thing that is new are two things for Editor VR. So a main menu item, which shows where this tool, which tells the system where this tool should show up, and an interface called iTool. And that just tells the system that you have a tool for it. And you don't have to register with anything. You don't talk to an Editor VR object. The system just picks this up and will automatically register that in the menu. So now let me launch Editor VR, and we'll take a look at that first iteration. Okay, so I'm just going to move over here, and then I will launch that first sequencer, and you can see that that's what we're showing there. Oh, I guess we still had these from your demo. Do we have the other one? No, you close it. Okay, so that's great, but I can't do anything with it. Also, you'll notice, and I left this as a step because you'll encounter this if you build your own tools, the lines are still there. And that's just because we're in edit mode, so we're just adding objects to the scene. So that's the second iteration that I created so that you would see. You just need to clean up after yourself for your tool. Unity will not be your mom. So what we do is we create a sequencer root transform. We put all of these lines underneath it, and we just destroy it when our tool goes away. So that's just the second step. Everything else is the same. I'm not going to demo that because you'll know that gets cleaned up. So moving to the next stage, we would also like to, if we delete, well, let me just show you first, before I do that. So now we'll select sequencer 2. And let's say I delete one of these things. Oop, no, I must have cloned that. Well, one thing we notice is that the lines aren't moving with the object, so we need to update our script for that. But also, if we delete it, the line sticks around too. So that would be the next sequence, next thing we'd want to make adjustments for in our tool. So what we do with that is we simply check whether a sequencer node still exists, and if it doesn't, then we're going to clean up after ones that were there. And actually, I'll just show a little bit more of that code. So this is in our update loop when we're iterating over all of our sequencer nodes. If the node isn't around, but we still have the line render, then we go and destroy that whole game object. So the same thing we're doing when our tool goes away, we're just doing that for a single line. Nope. Oh, I didn't clean it up from the previous session. Let me restart that. Okay, so if we select this guy now and we delete it, yeah, so our objects are now, yeah, and these now, if you move them, you see the lines update as well. All right, so the next step would be I actually want to wire up these things to different objects, and that's where you need more services from the from editor VR. So I need to know what I'm pointing over. I need to get the raycast from the scene. So so that will be our fourth iteration. And there are two new interfaces that are functionality injections. So the first one is I uses raycast results. So that just gives us a method called let's see where that is. 51. Oh yeah, right here. Get first game object. So we give it our ray origin, and that's the other thing we need from the system. So when we spawn a tool, you spawn it on a single hand, and you can request from editor VR what the ray origin is. And the reason why you request it from the system is there are different controllers in the system. And if you build a custom tool, you don't want to have to build something specific for Steam and specific for Oculus and then whatever other new hardware comes out. So we or any vendor could create their own custom controllers, put them in editor VR, and you wouldn't have to change your tools at all. You'll just get wherever on that controller the ray origin has been defined. So what you get from the system is a property that's set by editor VR, and it's the ray origin. So the coupling of those two things, or the use of those two things, allows us to get the object that is the first object for that ray. So we'll go ahead and demo that. And all I did for this was just simply to set a current node that we've selected, and I made a modification to where we draw the ray. If instead of it going to the next object that was actually set, it's as if I'm going to pick up the array and move it around. So moving towards our full tool, which it'll just be easier to demo it to you. Okay, so you'll see as I move over an object, I now have this ray that is along the pointer. But the point of this was just to show you that as I go over an object, I'm getting that raycast result, and then I now have something that I can wire up. So the final part of what we need from the system is we need to be able to get button presses. Again, you wouldn't want to have to build a tool specific to one vendor, so we provide you yet another interface, and it's called Standard Action Map. And this uses our new input system, although for editor VR it's a prototype right now that we're making use of. So that iStandard Action Map has you implement a new function called process input. And what you get from that is this action map, which gives you button presses. In our standard action map, it's just a single action. And that would be the trigger on the Rift, and on the Vive, it would also be the trigger for that. So what's neat is each controller could define what its main button is, and your tool wouldn't need to change. You would just use that default action. We have support for custom action maps if you need much more, like if you need the joystick or the secondary trigger. But this is a simple tool. We're just going to use the main trigger for that. And then the other thing you get from this method is you get a delegate called consume control. So what this does is when I press that button, I can consume it so no other tool below me or no other thing in the system will use that same button press. Just briefly, this code, we already had the selection part for the raycast. But what I do now is I check whether you're pressing down on the object first before I select it. And then after you do that, then while you have that held, you can drag it to another object and release. And that's that code right here. So while it's held, we're going to continue to consume that button press, and then when you release, then we're going to wire it up to whatever object you dropped it on. And that's our tool. That's the entirety of it. So, with 128 lines of code, we now have something that should hopefully allow us to build out VR functionality more intuitively. So I'm going to go into sequencer 5. And if I wanted to rewire this, I could go and drag that there. Wait, I must have not. And then I could drag this one here. And now I have a different order. And I could even create a loop if I wanted to. So one of the nice things of being able to stay in VR is I could just go right into playing it and try that out. And if that is too far, like Neo in the Matrix, you need something to exit, so I just put a cube there. It brings me back out of play mode, and then I'm back in Editor VR, and I can simply go and move that thing closer, go back into play mode. And so our iteration time has gone down quite a bit. The other thing, too, is for a designer, as long as they can use VR, then that's still too hard. So for a designer, you can build your own interfaces, and this is a very simple tool, but it doesn't really require a designer to know Unity. So however you want to collaborate, and that was that whole point of meeting your team where they're at, or in the languages that they like to speak in terms of UX. So another thing I could do is let me turn this tool off for a second. I could take this object and clone it, which you saw. So if this is just adding a new object to it, actually this is why we have the hotkey. I cloned it from this so it still has the same link there, but I could just wire that up that way, and then if I don't want one, I can just stop there. So let's fast forward now towards a later stage where we've started to add environment. And this is that same scene. I just started to throw more environmental pieces in here, and we'll make use of some of the other Editor VR features, like the project workspace. Yeah, and if I want more trees, I can just drag more trees onto here. And with the snapping that we have, it's really cool because if I go in and as I build out the level, And we have teleporters we added so we could build out more of the level that way. I might clone this. I'll show you a feature of locking because obviously I didn't want to select that. So now I won't select that anymore. But I can clone this one. Here, let me use that. And not that. This one. So like if I put this thing in here, like I can snap this to the ground and then I can snap this over to it. Then since it's a new one, I need to hook it up, so I just go and connect that. And then we will go into play. Hopefully we should see our new one out there, although this one is kind of difficult to hit. Well, physics having fun with that one. I guess I didn't maybe get it set up just right. So let me switch back. So just to recap, ultimately VR development I think you have to preview it in VR, so why not build it in VR? And iteration is key to that. So the more time you have to iterate on your projects, the better your projects are going to come out. And Editor VR is one option to do that. There are a lot of other authoring tools that are coming out. It's available now as an experimental build. So there's a blog post that initially unveiled it, but you can just search on or go to GitHub and there's links for all the downloads you need. And then for you software architects out there, I really hope that you might consider, using functionality injection for your own systems so that you can do these things agnostic of hardware platforms. And thank you. That's our